fluid mechanics, an example of flow in pipes. So we have two reservoirs, A and B, are connected with the length of 40 meter, and the diameter of the pipe casted with the cast iron pipe is 2 centimeter, and we have a fully open valve. Also, it's with sharp edge entrance and involves a swing check valve. The water level are both same, but reservoir A is pressurized by compressed air, and reservoir B is to atmosphere 88 kilopascal, and we have volume flow rate 1.2 liter per second. What we have to determine is the absolute air pressure on top of reservoir A. We take the water to be temperature 10 degrees Celsius. At 10 degrees Celsius, we have the density of the water. Density of the water is 999.7 kilogram per meter square, and the mu is 1.307. However, the loss coefficient for the sharp edge is 0.7. It's taken from the table. And for the check valve is set to be 2. And for the open gate, fully open gate valve is 0.2. And the roughness of the cast iron is 0.00026. We have to apply an equation so we can find a set of equations so we can find the absolute air pressure. First, we have to find the velocity, which is volume flow rate divided by area. The volume flow rate has to convert it to meter cubic per second, which is 1.2 times 10 to the power -3, divided by the areas pi d square, which is 2 centimeter. We have to convert it to meter, is 2 times 10 to the power -2 squared divided by 4, which is equal to 3.82 meter per second. And next, we have to apply the Reynolds number so we can see, is it turbulent or is it laminar flow? We'll see. So the density is 999.7 times the velocity 3.82 times the diameter is 2 divided by the mu is 1.307 times 10 power 3, which is equal to 58400. It seems that it's greater than 4,000, and once it's greater than 4,000, it means that it is turbulent flow, and the relative roughness is 0.00026 divided by the diameter, which is give us 0.013. So here is the equation of Reynolds of the turbulent. We can apply it and calculate it by Moody diagram or by calculator through a solver. -2 log 0.013 divided by 3.7, plus 2.51 divided by Reynolds, which is 58400. The result is 0.0424, the friction factor. And next we have to calculate the summation of the loss coefficient for the sharp edge check valve, the fully open gate valve, and so it's for the sharp, for the check valve +2, for the open is 0.2, which is equal to 307 +1. And now we can calculate, once we get all what we need, we can calculate the head loss, the total head loss, which is equal to 0.0424 times the length, which is 40 divided by 2 times 10 plus 3.7, the summation of the loss coefficient, times the velocity is 3.82 squared divided by 2 times the gravity, which is equal to 65.8 meter. Okay, here we go. We'll solve the last step to find the absolute air pressure is through the energy balance equation divided by the mass times the gravity, which is converted to be in the head loss equation. We don't have any turbines, we don't have any pump, even the elevation Z1, Z2, we don't have the level of yeah, it says here both are same the level of the water, so we have to neglect the velocities here. We have yes, we have the P1 and P2, P1 and P2, and the head loss, what is left. So the absolute air pressure is P equal to the atmosphere, it says, at reservoir B, which is P atmosphere plus the head loss times the density times the gravity. Here is the absolute pressure equation. So the atmosphere is said to be 88 kilopascal times the head loss 65.8 times the density 999.7 times the gravity 9.81. So the pressure is 733 times per Pascal.